Okay, so we're gonna give this one more try. Because I'm not sure if it's the device that I'm using that's having the issue or the USB port that I'm using that's having the issue that I was using. So I kind of switched them around. Um, I put the USB to Ethernet adapter into the USB port that my okay. So okay, to explain it better, uh, I have 3 USB ports on this laptop. Leave one of them aside, it's being used for something else. 2 of them that I have, one has the audio interface connected to it, and the other has the USB to Ethernet adapter connected to it. So I kept getting this issue where the thing kept disconnecting for some reason. I don't know if it's the Ethernet adapter kept disconnecting. I don't know if it's something wrong with the USB port itself or if it's the adapter, because this has been a thing. Like usually I have to how do I say this? Usually I have to disconnect and reconnect the thing at least once a day. Otherwise, when the laptop goes to sleep and then I wake it back up, the thing is going to be disconnected. So then uh, I have to unplug the adapter and plug it back in. Anyways, so far everything seems good, which kind of concerning. Actually, I need to see how the audio sounds on stream. There's going to be feedback. All right, dude. It seems to be fine so far. Fortunately, uh, the audio interface is not constantly disconnecting. Hopefully, it remains that way. Because, like, I don't know, man. This laptop, it only has 3 USB ports. All 3 of them are in use. Something I could do is I could go buy a USB hub that's like a powered one, so that I can connect more things to it, and then I'll connect that to my laptop. But like I don't know if that works in all situations, because I've had situations where, like, for example, if I tried to connect a USB extension to one of the ports, and then I try to connect my wireless keyboard and mouse to that extension, it doesn't work. But I have had actually, no, that's not a good example. The USB to Ethernet port, that's a good example. That doesn't work. The keyboard thing that I was just saying, that actually does work. That wasn't a good example. But yeah, the USB to Ethernet thing, it's a good example of, like, in certain scenarios it just doesn't work. To be fair, I've also had situations where the wireless keyboard and mouse receiver, it wouldn't work in certain situations, but it would work in some other situations. So, like, it works here, it works with an extension. It of course, it also works if you directly plug it into the port, but I've tried plugging it into a non-powered USB hub. It was one of those cheap ones that you get. So, like, those are kind of hit or miss. Like, maybe it works, maybe it doesn't. If the device that you are trying to use is not working well with it, then you have to connect that device directly to the USB port. But yeah, that is also why I want to get a powered one, just so that the devices that I'm connecting to it, they're actually able to work properly. But yeah, dude. Okay, so far things seem fine. Hopefully they remain fine. Hopefully my actually I'm not sure what this is connected to. Yeah, dude. I'm not sure what this is. I don't want to mess around with the wires right now, just in case, because I don't want to pull on the audio interface wire, just in case, a loose connection would cause it to disconnect. And like I'm streaming right now, so I don't know what that's gonna sound like on stream. So yeah, I'm not gonna mess with that. Anyways, let's get to doing some studies. Uh, where are we? Okay, so I can minimize this and I can. So here is where we are at. So in the past couple of days, reading up further on the C Sharp tap model, I learned that. So okay, prior to getting into the tap model, I had this assumption that just using the tap model by itself, it makes it so there's multi-threading going on. So like each task that you set up, it automatically dispatches it to a different thread. That's not true. That can be true in some cases depending on what you do, but like by default, that's not the default behavior. Another thing I didn't take into account when I was getting so excited about like multi-threading and all that stuff is the cost of context switching, the cost of I'm not sure if it's called context switching or something else, but the whole thing of switching from one thread to another, that has its own cost. So you should only offload or try to offload the calculation or whatever operation it is. You should only try to offload it to a different thread if it's gonna take a significant amount of time, or if it's long enough that you don't want the main thread to suffer because of it. But like it has to be justifiable in some way, in the sense that sure, you're getting the work done, but like would you be able to do it faster if it was on the same thread? And if the work is small enough that you could do it faster on the main thread, you should probably stick to doing it on the main thread. But because like there is a certain overhead of switching between the threads. So like I think a better way to put it is, if that overhead of switching between threads somehow overshadows, or somehow somehow that overhead is bigger than the amount of time it would take for your whatever calculation or operation you're trying to do, if the overhead ends up being bigger, then there's no point of offloading your calculation to a different thread, because you're not going to be seeing a performance gain there, you're going to be seeing a performance loss. So I clearly need to read up more on multi-threading. The good news, however, is that even with the task-based asynchronous programming model, you do have the TPL, which is the thread parallel something, task parallel library. So this does give us the option to run tasks like in parallel, or run tasks concurrently. But again, it's even here, I believe that they're going to mention the same thing, like if only do it if you have a good reason to do it. I think I'm going to have a good reason to do it. I'm going to have to see how I want to go about setting this whole thing up, because with my VTuber app, I'm gonna have certain things that I'm gonna be doing constantly. So like, I need to find a way to like assign a thread and just have everything be assign a specific operation that I know is going to be happening on that's going to be happening constantly. I could assign that to a different thread, and then each time I could like keep reading from that. But yeah, I it's I'm glad that I understood this early on, that just using the tap model by itself doesn't equal to multi-threading. um, it could equal to multi-threading, like for example if you're using task.run. But if you're doing other stuff, there's another thing to take into account, is like you have CPU bound operations and you have IO bound operations. IO bound is not necessarily, I thought IO bound, like I wasn't really thinking about it from like the hardware perspective, in the sense input output operations, they to a certain extent they depend on the hardware as well. Like you're reading and writing to a file, that's the actual like hard drive, right? So to a certain extent it depends on the speed of that hardware as well, how quickly your hardware is able to complete that operation. The CPU can't really force it to go faster, so it'll take however long it takes, and it'll complete. And through the through the tap model, what you could do is you could avoid having your main thread blocked during this process. Like while this operation is completing, your main thread is not going to be blocked. It's still, everything is still, apparently everything is still happening on the main thread, on like the one thread. You can offload certain things to a different thread. Like for example, if it's an actual CPU bound thing where you're doing like some kind of calculation, then yes, you can offload it to a different thread if the work is big enough that you're able to justify the cost of the switch that happens. But if it's an IO bound thing, then like multi-threading, you can't really force it to give you more performance just by adding multi-threading. But with the tap model, you are able to make it so while that operation completes, your main thread is not blocked, so you still have you're still able to carry on doing whatever operations you want. But yeah, back to what I was saying, I'm glad that I found out that it's not like tap doesn't equal to multi-threading. It does give you the option, but the whole idea behind tap is something else. The whole idea behind tap is that you are able to do things on the main thread in a non-blocking way. That's the important thing about. I feel like that's the problem that they were trying to tackle. You are able to run operations on the main thread in a non-blocking way, and also have a decent syntax to specify the language that describes these tasks that you want to do, these operations that you want to do. But yeah, it seems like I have a couple of things to get into. So at some point I definitely want to get into, where are we at? So at some point I definitely want to get into TPL. Once I have a better idea of tap, because TPL, it's a parallel version of not parallel version, but it's a library that allows you to have parallelism when using tap. That's a better way to put it. I was trying to put it in lesser words, but that just came out wrong. Okay, so anyways, yeah, eventually I do want to get into TPL as well, because I feel like that's also going to be beneficial. And of course, yeah, I was looking for multi-threading, but so this has kind of taught me something, that like multi-threading is not always multi-threading doesn't always equal a performance gain. Like, something important that I didn't take into account is the fact that there is some work that has to be done when this switch is happening, like between the threads. It's not as simple as, oh, the CPU tells so and so thread that, hey, do so and so work. No, there's a bunch of work that the CPU has to do. So I need to read up more on multi-threading to understand exactly what happens behind the scenes. And once I get a better idea, I feel like I'll be able to design my programs a lot more better around that, because I definitely want to use multi-threading. I want to use it as much as I can, but at the same time, because there's that overhead of switching between threads, I want to make sure that whatever work I'm doing on the other thread, it's worth the cost. So it has to be big enough. Otherwise, I'm not going to bother offloading it. I'll keep it on the main thread. Another thing I could do is I could try to organize like batches of work and see if that could run, that entire batch could run on a different thread. I could try doing something like that. So basically give it enough work that it becomes feasible, or it makes sense to offload it onto a different thread. Like, I'll give it that much work. That's another way that I could go about this. Right now I'm just brainstorming. But yeah, I was in this. Yeah, I'm almost done reading this thing. Once I'm done reading this, then we can move on to this. This thing just gives us like the different async return types. It probably explains each one of them as well. But yeah, wait, process asynchronous tasks as they complete. Okay, let's well, yeah, okay, so I'm gonna need to wait, asynchronous file access. This was another thing that I was assuming it's gonna be happening on a different thread, but from what I've been reading, apparently doing IO based stuff on a different thread it's not always good. In fact, a lot of people are sort of advising against doing it on a different thread. But I guess that would depend on, the situation. Like, if the work you're trying to do is that big, then yeah, sure. But yeah, I don't know. I'm gonna have to see. Hold on. So yeah, I was early on, I was assuming, like, prior to going deep into the tap model, I was assuming that, hey, doing tap model stuff, or creating a task basically equals creating a new thread, but that's not the case. What the tap model does is, I feel like I'm just repeating myself at this point, but I don't care. So what the tap model does is, the idea behind it is that you are able to do operations that would otherwise be blocking the main thread. You are able to do them in a non-blocking way. So they're still happening on the same thread, but they are not blocking the main thread. I'm still trying to understand the way that the runtime is able to do this. It apparently it creates some kind of continuation. Yeah, I'm gonna need to read up more on this, because so far I'm slowly getting an idea of how it goes about this. From like a higher level, I definitely have an idea. I want to understand from a lower level as well. But yeah, from a higher level, the basic idea is that you create a task, right? And then once that task has been created, it's gonna start doing its work. And whenever you think that task has completed, you can await that task. meaning retrieve the value from the task. So when the program hits that point, that await point, it's gonna pause execution and wait for that task to complete. However, in the meantime, like before you actually add that await statement, once you've created the task, it's going to start doing the work, right? You create a variable that's going to hold the task, and then it starts doing whatever work it has to do. Then you are free to do whatever else you want to do. So that's where the non-blocking thing comes in. You're free to do whatever else you want to do. It returns control back to you. You can do whatever extra work you want to do. And after that, eventually you can await the result of the task. So you can await this task. And if the task is already completed by that time, you'll get the result immediately. Otherwise, you're going to have to wait for the task to complete. But the whole idea is that you create the task, and the task starts executing. It starts, doing its thing, its work. And then you're free to do whatever other work you want. So you can use this to your advantage, to where you can do a bunch of work while that task is completing. And after you're done with this bunch of extra work, you can then await that task. So by that time, you can just assume that the task is going to be complete by that time. So in this way, you're able to manage your time better, and everything is still happening on the main thread, but you're just able to divide the time in a much better way. You're able to give all of the operations a decent amount of time without blocking the main thread and waiting for an operation to complete.
YouTube Premium is ad-free YouTube and the YouTube Music app altogether.
Okay, so I need to finish reading this. Hopefully I'll finish reading this entire thing today. I was here. Okay, the async-based approach to asynchronous programming is preferable to existing approach. I think I'm done with this. Yeah, I think I'm done with it. Anyways, let's carry on reading. To existing approaches in almost every case. In particular, this approach is better than the background worker class for IO-bound operations because the code is simpler and you don't have to guard against race conditions. In combination with the task.run method, async programming is better than background worker for CPU-bound operations because async programming separates the coordination details of running your code from the work that task.run transfers to the thread pool. Okay, async and await. If you specify that a method is async, by using the async modifier, you enable the following two capabilities. The marked async method can use await to designate suspension points. The await operator tells the compiler that the async method can't continue past that point until the awaited asynchronous operation is complete. In the meantime, control returns to the caller of the async method. The suspension of an async method at an await expression doesn't constitute an exit from the method. And finally, blocks don't run. Finally, as in try catch finally, I think. Yeah, I think it's try catch finally. Okay, so that's the first point. The second point is the marked async method can itself be awaited by methods that call it. That makes sense. Because it's an async method. Hold on, actually no. Does an async method always have to return a task? I'm gonna have to test that. I'll test that out. Because I know it can return a task along with a value, or it can return a task that's just a task and doesn't return a value. But I don't think it can just return a value. Like it has to return a task that has that value. Or a task of type T, basically. I think so. I'm gonna have to test that out. Okay, next. An async method typically contains one or more occurrences of an await operator, but the absence of await expressions doesn't cause a compilation error. If an async method doesn't use an await operator to mask, why do I keep saying mask? To mark a suspension point, the method executes as a synchronous method despite the async modifier. All right, okay, that makes sense. That makes sense. Because, like, if it's not awaiting, that means, like, it doesn't have to be asynchronous, right? So if there's no await in the first place, then what's the point of asynchrony there? Man, these past few days, like, this has kind of taught me that, like, I probably had the wrong idea of what asynchronous programming is. Yeah, because now I'm wondering if I need to go look into how asynchronous programming works in Python and Rust. Because I've looked into asynchronous programming in Python a little bit, not too much, and I've only read up on async programming in Rust. So I'm not sure if async equals multi-threading in either of those languages, like automatically, or if, it's a similar situation to this. I should be hydrating because for the past like 5 to 10 minutes I've been having trouble talking, and it's probably only gonna get worse. I need to find different times to stream, dude. Water, man. It's the good shit. Okay. Um so async and await are contextual keywords for, yeah, okay, that's fine. Return types and parameters. An async method typically returns a task. So this is what I was talking about earlier. An async method typically returns a task or a task t result, in which case the t result is some kind of type. So this is when the async method actually returns a value. But like with the task, with only task, it doesn't return anything to my knowledge. Actually, I'm gonna have to test that out as well because like I don't remember. Okay, inside an async method, an await operator is applied to a task that's returned from a call to another async method. You specify task to result as the return type if the method contains a return statement that specifies an operand of type T result. You use task as the return type if the method has no return statement, or has a return statement that doesn't return an operand.
يوتيوب ميوزك بريميوم تمنحك تحكما كاملا في أغانيك بلا إعلانات لتشغلها بدون إنترنت والاستمرار في تشغيلها في
Okay.
الخلفية.
You can also specify any other return type, provided that the type includes a getAwaiter method. I didn't know that. Okay. Value task is an example of such a type. It is available in the so and so so and so. Value task. I haven't looked into that. The following example shows how. Okay, an ad is going to be starting soon. So whenever it does start, I'll just be quiet for 30 seconds. But yeah, okay. Following example shows how to declare and call a method that returns a task to your result and or a task.
You tell me how you've been, and now my head won't slow down. Shouldn't stay.
All right, so async task so and so. So I'm wondering if I could, because like I want to test this out. Okay, we're gonna keep multi-threading aside for a second. We're gonna keep multi-threading aside like completely until I properly understand the overhead. Okay, there's an ad playing, so I'm gonna be quiet for 30 seconds. All right, welcome back. So, yeah, we're gonna keep multi-threading aside until I fully understand how multi-threading is done. Like not just a high-level understanding, but like on the lower level, how exactly it is done. So like I need to understand what, or you know what? No, I want to get a high-level understanding first of exactly what is happening during multi-threading. What exactly is happening when a new thread is dispatched, and then we give it some work to do, and then we read back the result from that thread. Like what all happens in between that? Because I feel like only then I'm going to be able to understand whether multi-threading is worth it for certain situations or not. It can definitely be worth it if you have like a bunch of work that you need to do. But like I need to see to what extent it's going to be useful for me to offload the calculation onto a different thread, especially if it's something I'm doing quite often. I definitely need to look into sorry about that. I'm watching Lord Aethelstan's stream. Something funny happened. Okay, anyways, I wanna write an async method that does a bunch of work in it, and then offload. Because like previously, like back when I was assuming that it's C# tap equals multi-threading. I would constantly check the thread ID just to confirm that the calculation is happening on a different thread, and it was happening when I used task.run. But for the time being, just to get a better understanding of the tap model, I'm going to keep multi-threading aside. Once I have a better handle on the tap model, once I have a better understanding of how things work, then I can move on to multi-threading, because there's a couple more things in the tap model that I need to look into. It's not so like there's this, we have single tasks, right? But let's say you have a couple of tasks that you need to complete. Like let's say you have 3 or 4 tasks that you need all of them to complete before you can do something else. So in those situations, you use something called task.whenAll, I think. I don't remember exactly what the name was. And then you also have another called when one, I think. But basically the idea is like with when all, it is when every single task that's mentioned in the list has been completed, only then this task is going to return. Or only then it's going to return successful. And with when one, I don't remember what the other one was called. Was it when one or one each or when each? Something along those lines. But the idea with it is at least one of the tasks that's mentioned in the list has to complete. All of them don't have to complete. So think of it as one of them is and. So like, this task and this task and this task and this task. So like all of them have to complete in order for the thing to return true. And then the other one is or. So it's this task or this task or this task or this task. If either one of them completes, it's going to return true. And I think there might be a couple other methods as well that I should be looking into, because like these are going to be useful, especially if I want to like divide up the if I want to like break up the work into multiple steps. I forgot what I was talking about. So I'm going to carry on with this. Okay, so what we see here is this, and then we create a task and do this. Okay, so far what I've been doing is, like, if you look at my code, I've been using task.run, and then inside that I'll create an action, an anonymous function, like with a lambda operator and all. But like you can do it in this way as well if you're just using tasks, or task key result and stuff. You don't have to do task.run. Initially I think I got into the habit of using task.run because I was trying to find a way. Funny enough, I wasn't even like, back then I was assuming that it was all multi-threaded, just because you're using tap, so tap equals multi-threading. I had that misconception at the time. But the funny thing is, I didn't start using task.run because of that. I started using task.run at the time because I didn't want to add the async modifier, and I didn't want to add the task keyword in my main method. I wanted the main method to just be, static void main. Or rather, I wanted to find a way to do async stuff without having to add the async keyword and or the async modifier and the task keyword in the main method's signature. But now that I know that that can probably have some adverse effects, I'm sticking with, just adding the keyword and the modifier. Okay, so here it is explaining how this works. So this is the task method. This returns an int. So we create a variable for the task. The task is created. The task probably also starts running at this point. Like once you call this, it probably also starts running. However, it's not blocking the main thread. Which is it's kind of interesting to think about. It's not blocking the main thread. It's still running on the main thread, but it's not blocking the main thread. That's kind of interesting. I need to read this again. I need to read some of this stuff again. So async methods are intended to be non-blocking operations, and await expression in an async method doesn't block the current method while the awaited task is running. Instead, the expression signs up, this is the interesting part, the expression signs up the rest of the method as a continuation and returns control to the caller of the async method. Okay, so what I'm just, sort of just visualizing how this is working, right? This thing happens, right? And then this thing happens, this thing gets called, right? So then the method starts executing, and then okay, so we do int hours equals 0, and then we do this await task dot delay, right? So at this point, which I mean it's delaying for 0 milliseconds, which I mean this is just an example. So at this point, I'm guessing it returns control back to the calling method, right? Let's say like this is like, in its own. Actually, I should look into local async methods, like how would that system work. I should look into that. But anyways, so it returns control back over here, at which point we go to the next line. Because the control has been returned, the method hasn't returned a value yet, but we have returned our the control back to this point. I hope I'm visualizing this right. So we await, at that point we return the thing back. We return control back. I'm losing my words, dude. I don't know if it's just that I'm tired or if I need more water. Give me a second. Okay, so back to this. So it await returns control back. Am I right to assume that? Let's go back here and oh, you know what? Yeah, let's open these up as well. Await operator asynchronously await for a task to complete. The await operator suspends evaluation of the enclosing async. Okay. The await operator suspends evaluation of the enclosing async method until the asynchronous operation represented by its operand completes. The await operator suspends evaluation of the enclosing async method. Okay, until the asynchronous operation represented by its operand completes. When the asynchronous operation completes, the await operator returns the result of the operation, if any. When the await operator is applied to the operand that represents an already completed operation, it returns the result. It returns the result of It returns the result of the operation immediately without suspension of the enclosing method. The await operator doesn't block the thread that evaluates the async method. When the await operator suspends the enclosing async method, the control returns to the caller method. All right. So yeah, I'm right to assume what I just assumed. Right. So it's returning control back here, and then this is able to carry on executing. But like, what's in this line is we basically are awaiting this task's result. So this is then going to go back to this. So this in this situation, the await is being used on a task. So it's going to await the result of this. Like at this point, it should be done. So this should then be able to carry on executing from here without needing to, go over it again and all that. This should then be able to carry on executing from here. And at that point, it's going to return the hours, which is 0. All right. Oh, this is interesting. So this is a single line way of doing it. That is interesting. I need to look into possible any differences between these two, like possible pros and cons of each method, each way of doing things. All right. So then next we have this get task async, which doesn't return anything. So then we just create this task. It starts running, and then it comes here, and then await is hit. So I'm guessing it then returns back here, at which point it it gets the result. And then the single line version of that is just await this. So okay, let's look into what's going on here. Await this. I'm curious about this because it seems like this would then be like it doesn't give the chance to run, right? Or is it that the compiler handles that for us? Okay, let's see. It might be explaining over here. Yeah. Each return task represents ongoing work. A task encapsulates information about the state of the asynchronous process and eventually either the final result from the process. Wait. A task encapsulates information about the state of the asynchronous process and eventually either the final result from the process or the exception that the process raises if it doesn't succeed. Okay. An async method can also have a void return type. This return type is used primarily to define event handlers, where a void return type is required. Async event handlers often serve as the starting point for async programs. An async method that has a void return type can't be awaited, and the caller of a void returning method can't catch any exceptions that the method draws. An async method can't declare in, ref, or out parameters, but the method can call methods that have such parameters. Similarly, an async method can't return a value by reference, although it can call methods with ref return values. Okay. Asynchronous APIs in Windows runtime programming have one of the following return types. Okay. Okay. All right, dude. I was hoping that I would be able to stream a little longer, but I'm just not able to. I will try to stream again tomorrow. I'll try my best. It's just that the timing is a little, off. Maybe I could wake up and then start streaming directly. I'll have to see. Um, I'm gonna carry on with this. I'm gonna carry on reading. I'm gonna do some practicing and stuff. Um, but yeah, dude, that's gonna be it for today. I hope you guys have a nice day, and I'll see you all next time. Peace.